Yeah, I think we can start now. For those of us who haven't been able to join today, we are recording the session and we will be uploading this webinar onto the Testsigma site. Let me introduce myself. I'm Mahesh Yadav. I'm a senior product manager at Testsigma, and we are building the world's first continuous autonomous test engineering platform. You can contact me at any point of time at mahesh@testsigma.com, or you can connect to me on LinkedIn as well. If you have any questions, please feel free to ask, raise your hand, write a message on the group. And I think Lavanya is right there. She's going to take up those questions and send it over to me or my team. We have an excellent team who's working behind the scenes, the tech team at Testsigma. So we'll just start with the agenda. Let me have a look. Yeah. So the agenda, as it's seen on the presentation. First, we'll try and understand what artificial intelligence really is. So the whole idea of this presentation, of this discussion or webinar, is to first understand. Let's try and bell the cat. So we'll understand what the cat is, and then we'll understand what the bell is, and then we'll understand what is the best way to bell the cat. Right. So here, artificial intelligence is our cat, or automation testing can be also considered as a cat. So we'll understand what artificial intelligence really is, the current state of artificial intelligence, what is being done in the industry, what is automation testing. We'll define automation testing and see what are the current challenges that we're facing. Current state of artificial intelligence in automation testing. What is the industry doing in terms of using artificial intelligence in testing, whether it be web application testing or API testing or mobile application testing. So once that's done, we will also try and understand what the right approach should be and what the Testsigma approach is going to be, right? And then we'll discuss a couple of questions. We have received a lot of questions from the infinite number of people who have registered to this webinar, but we will not be able to take up all those questions. So what we are going to do is we're going to make sure that we send an email to you specifically. We're going to pick up 5 to 6 questions. All the other questions would be answered over email, and my team is going to ensure that. So we'll move on to the next slide. So what is artificial intelligence really? Whenever we talk about artificial intelligence, we use machine learning and artificial intelligence in the same line, which is considered as wrong, because machine learning is a part of artificial intelligence. As you see, machine learning is simply a statistical set of models or basic statistics, basic math that is used for predictive or for predictions or classifications, right? So machine learning or these statistical models have been there in the industry for the last 30, 40 years, and they are not new to the industry at all. Neural networks, for that matter, has been there for the last 10 years, and they are majorly used for classification purposes. Now, we're not going to get into specifics of machine learning or neural networks or deep learning for that matter. What we will try and do is we will try and connect artificial intelligence to automation testing, focusing mainly on the challenges of automation testing and how we can solve those problems, right? So deep learning doesn't mean that it's profound or really good or really smart. It just means it's got a lot of layers or a lot of features of neural networks, complicated neural networks. And deep learning is the latest. We'll also understand a couple of examples, like what is John Deere doing in agri-tech, agricultural tech, how they are solving problems for farmers, how they are reducing the expenditures that farmers incur. We have IBM Watson. That's a big use case for deep learning. How is IBM working in the healthcare industry? We will try and see how deep we can go into these discussions, but we'll keep the discussion to around 20 to 30 minutes tops, and then we'll go ahead into questions, if any. Right. So artificial intelligence is also about rule engines. We've had rule engines forever and ever. For the last 20, 30 years, we've been developing applications, and we call this as the yesteryear of AI. This is the old version of AI. We have had rule engines. Natural language processing has also recently come up. We are also using NLPs within our application in Testsigma for test authoring. Right. So this is mostly used for test authoring, creating test cases. We'll talk about this as well. Mostly artificial intelligence also includes a part of what we call as robotic process automation. Robotic process automation is mostly a dumbed down level of artificial intelligence. It's a very basic level of artificial intelligence, but it's also growing right now. It's also getting smarter, but we have not included it in the list here. most of the companies, they don't just have machine learning. They will always have a combination of these or a custom integration of all of these, including rule engines, neural networks. It can be machine learning algorithms to classify data. And build it onto a cognitive cloud. So that's number 5. So this in totality is what is artificial intelligence. Being inclusive, being the kind of inclusive people we are, we have tried to include all of these into the definitions of artificial intelligence, so that you don't get confused as to what we are trying to solve here. Now let's go ahead into the next slide. So I wanted us to start this discussion on a funny note, just so that we are also having a little bit of fun. This is called the Alexa game, and what you see on the screen is Jimmy Fallon from this tonight's show. Right? You also see John Oliver. So they are playing a game in which they have to make Alexa say a certain word, and that word here is leprechaun. A leprechaun is an Irish folklore, a person from the Irish folklore. He is supposed to be a shoemaker. He also has a pot of gold which he hides in deep inside the Irish countryside. And whoever captures this guy, he gets that pot of gold. So now Jimmy Fallon is going to try and make Alexa say this word. And let's have a look at. I hope the audio is audible. So let's have a look at that.
Okay, so I have to get it to say leprechaun. Now, if I don't get it, then you go. You try to give it a shot. All right, here we go. Alexa, what fictional cartoon character is associated with the pot of gold?
Here's something I found on the web. According to grumpycats.com, cartoon Grumpy Cat frowns next to 4 shamrocks with pot of gold, and I hope it's empty printed around her on a cute green shirt.
Makes 0 sense.
Alexa's got to spend less time on grumpycat.com. If that's where she's getting all her news, we're in real trouble.
So yeah, Alexa is a beloved friend. I use Alexa every day to play music. Alexa, as well as Siri, all these devices, they work on artificial intelligence or machine learning. Was there a question somewhere there? I heard somebody asking something. If it's the Testsigma team, can you please go on mute, please? So the idea of showing you this video is to bring things to perspective. Amazon has built Alexa, and today Alexa is running on machine learning, artificial intelligence, blah, blah, blah. But whenever you ask a question to Alexa, this is the kind of response that you receive. It's an amazing device, but this puts things into context as to how you can use artificial intelligence, or what is necessary, what is the problem, and what is going to be the solution in the future, right? So let's go ahead in the next slide. So we've brought to you a list of things that AI today can do. But if you look at the right side, there's a column called self-aware or intelligence. Are the devices that we have created, are they really self-aware? They're not. We have not reached that point yet, right? So we'll just talk about what are the applications that can be performed by which were performed by humans, and which are right now being supported by artificial intelligence and machine learning algorithms. First of all, we have analyzed numbers. So numbers, you consider the fintech industry, it generates petabytes of data every single day, stock movements to lending rates to all sorts of bank rates and everything else, right? So all of these are currently being worked on by human support in terms of business intelligence, or in terms of a hypothesis-driven analytics, where we say, okay, we have a hypothesis and we are going to churn some numbers and finally end up say, this is where the stock is going to lead to in the next week. This is going to be the target, and this is going to be the stop loss for this certain stock, right? So model data management or operational analytics is what we are currently doing. And context awareness, in terms of context awareness, we're using neural nets as well as automated machine learning right now. Right? So analyzing numbers, this next one is digest words or images, where we are using, from Testsigma, we are digesting words. We have created NLPs, a set of instructions wherein automation test engineers can create tests directly without even knowing how to write a test case, right? You don't need to know scripting languages, you don't need to know anything much, but you'll be able to write a test case directly. Image recognition is being used in certain parts of the application. We'll talk about it a little later. But right now, self-awareness throughout the industry has not been achieved, whether it be in image recognition or text recognition or text creation, right? Digital tasks, admin and decisions. We talk about rule engines as well as we talk about robotic process automation tools, which are basically providing you the support for back office operations. Like it can be KYC. Currently, most of the banks have made know your customer as a process which is mandatory for every single customer, right? And most of it is on paper right now. And the way robotic process automation currently works is it can work only when there is a workflow involved. So, for example, you are an HR person and you have to onboard a candidate. The offer letter is released automatically by using these tools like Automation Anywhere. And starting from the point of where the offer letter is created to distributed to getting it signed, and then that set of processes that are involved in onboarding, these are all called as workflows, and only when there are workflows can these robotic process automation and rule engines work. So that's why in the column that says context awareness and learning, we have nothing. There is no context awareness when it comes to these pieces of artificial intelligence. They are the dumbed down, they're the last level of artificial intelligence. Self-awareness, yes, there is absolutely no self-awareness yet, right? Performing physical tasks. If you've seen Boston Dynamics, the kind of robots that they've created, robotic dogs. So they have created robotic dogs which can right now take care of 24/7 surveillance of acres and acres of farmland. So these dogs walk around the whole campus of a farmland and they do surveillance and they record photos, record images, record audio, record video of any trespassers. Expensive, yes, but are they doing the job? Yes. Very nice devices. You have to check out what Boston Dynamics is doing right now. Fully autonomous, yes. The vehicles being sent to Mars, it might be something else. But are they self-aware right now? Do you have robots which are doing industrial operations in Amazon, in Amazon's warehouses? Are they self-aware? Absolutely not. So we have not yet reached that level. The great convergence on the right-hand side. So basically, when all of these things are self-aware, we are going to call it as a great convergence. It's going to take time, right? So here we just define what AI is today. Let's move on to the next slide and say the actual applications. The applications can range from image recognition, speech recognition, to intelligent bots, majorly prediction and classification. And the methods that are being used, as we spoke before, neural networks, deep learning, machine learning, rule engines, and NLPs. And at the base of all of this is statistics, math, logic, and semantics. Semantics is a part of statistics which deals with meaning, right? So just wanted to put things into perspective as to what AI is in very simple terms and what are its applications and what are the kind of methods that are being used. We are not going to get into in-depth deep learning or machine learning or neural networks because right now for today's agenda, we don't really need it. But if you guys want to have a discussion on these topics, we can always have another webinar, or you can send out an email to us or connect to us on LinkedIn. My team is always ready to answer questions. So coming back to the biggest part and the broadest part of artificial intelligence, which is machine learning. Basically, these are mathematical approaches, which are analytical approaches. You can see episodically with human intervention, these things can be done better, right? An action that we are currently doing, something like a linear regression or a multiple regression at the basic level, which basically predicts, is it going to rain tomorrow? This can be done in a better way by using data, by using machine learning algorithms, which will eventually predict if it's going to rain tomorrow, or if there's going to be a hailstorm tomorrow, if there's going to be a tsunami tomorrow, right? So the tasks of these machine learning algorithms majorly are either prediction or of classifying data as something. For example, if you want to say this is an image of a cat, so dear machine learning algorithm, tell me if this is a picture of a cat. Right? We classify data. It can work on structured data or unstructured data. We are going to talk a lot about data in the next couple of slides. Mostly in the industry right now, we use supervised learning a lot more than unsupervised learning. We are not there yet, right? A big example for the application of machine learning here is credit score analytics. It's been done, there has been credit score analytics ever since the banking sector started, ever since the first bank started, ever since people started lending money to other people, there has been credit score analytics. But right now, we are using machine learning algorithms to decide if we have to lend money to a person, if he is credit worthy, if he or she is credit worthy, and he or she will pay us back at the right time. So this is a very nice example for machine learning algorithms. We'll go ahead and talk about data, right? Andrew Ng is the founder of deeplearning.ai, and he has worked with a lot of companies like Google or Facebook or the FANG companies, Facebook, Amazon. So he, in one of his talks, he says that he can build a team of the best artificial intelligence, best machine learning, deep learning engineers in the world, but he cannot in any way, even with an awesome team, replicate what Google is doing right now. And the difference between what Google is doing right now and why he can't do it is because of the kind of data asset that Google holds. Google has collected so much of data. They have a unique set of data with which they are running their algorithms, and they are providing results which can never be replicated by anyone else. And that's the difference between Google and someone else, right? I can't build a new search algorithm. I can't build a new search website and be as good as Google. I can have the best of engineers, but we can't do that. So the most important piece of the whole puzzle of using AI into applications, whether it's test automation or something else, is the kind of data that you're collecting. And the biggest point that here we need to understand is the kind of data that we need. If we are just going to pick up a set of data that's publicly available, which is already being consumed by hundreds of other companies, we are using data that's publicly available, which is copied, which is really not real-time data, then we are only going to end up with results which are going to be similar to that of another company, right? So for example, what John Deere did, the tech team behind John Deere, when they were in Stanford University, when they were students, they started clicking pictures of a lot of plants and soil, and they collected so much data that they grew this whole company into being a digitally transformed AI-based company, which is helping customers now, right? Now the John Deere systems are so capable of artificial intelligence that all they have to do is just send out a drone. The drones click pictures of plants and vegetables and the whatever is on the farm. And just by looking at the pictures, their systems their intelligence systems give out the result if a farmer has to apply that pesticide or a herbicide onto that or not, right? Growing plants. So the biggest problem the farming industry is facing right now is excessive use of herbicides or pesticides, for that matter. John Deere has collected so much unique data, alternative data, that they have been able to provide you these results out of the box, right? So the most important puzzle in the whole artificial intelligence being used problem is to have unique set of data, and not just have the unique set of data, but you also have to assess it and clean it and create metadata for it. And the biggest problem is connecting data and storing data and connecting data to your product. How are you going to use that data within your product, right? So one biggest suggestion that artificial intelligence experts give is that these problems should always be undertaken by the business team and not the engineers. The engineers know how to write algorithms, but it's the business in an organization that has to understand how this data can be used and how products can be built out of it, right? And we are doing that in Testsigma. We have an excellent set of engineers who understand the importance of artificial intelligence and how to really help and create a better product, right? So we've built a world-class product. We're solving the problem of quality engineering, bringing back quality into the quality assurance ecosystem. Now, going to the next slide. So what are you going to really use, right, in terms of data? Is it going to be big data? Is it going to be small data? So people have started, if you look at what companies, bigger organizations are doing, the Infosys of the world, the Capgeminis of the world, the biggest banking, IT tech companies, they're all creating data lakes and data ponds and data warehouses and data oceans and stuff, right? But is it really effective? You can have a data lake, but do you have the right set of data? Most of the management, most of the top level, high level management doesn't understand the actual use cases of artificial intelligence. And that's why we need webinars like this to make people in the upper management understand that this is where you can use artificial intelligence, and there are use cases where you can't really use it, right? So let's get into the next slide. So we come back to supervised learning from machine learning. What is supervised learning in reality? It's an A to B mapping. It's an input to output mapping, right? So if you have a good set of data, everything is fine. If you have garbage, it's going to be simply garbage in and garbage out. So you put in garbage into an algorithm, it generates garbage. And this is probably what happened with IBM Watson. I have a set of documents that gives you a brief description of what happened to IBM Watson and why it failed. If you are interested, please write back to me at mahesh@testsigma.com and I'll send you that document, right? In healthcare, there were huge use cases for artificial intelligence to be used. It can be to find early detection of kidney diseases. It can be cancer detection. It can be for robotic surgeries, right? These were prominent use cases which IBM Watson promised when it was, when it came to the market in 2014, but eventually all that sort of faded out. And right now, very few of its projects are still running in the major healthcare organizations. It can be Mount Sinai Hospital or the biggest pharmaceutical companies. It was supposed to be used for clinical trials and clinical drug development. As you know, when it takes around 12 years to create a vaccine for anything, it might be Ebola, it might be Corona, it might be anything, right? It takes around 12 years. But the reason why it takes so much time is the amount of the data that is collected during every single one of these stages of clinical drug development. It takes a long time to process these things at each stage, right? And artificial intelligence came up as a savior, and IBM Watson promised that we will do it, but they couldn't really do it. So the idea is you need to have the right set of data and you need to have the right set of use cases, right? So the biggest, now when I say image, is it really you? The biggest achievements of the industry in artificial intelligence has been to just have a look at a picture of a cat and say if this is really a cat or not. That's humankind's biggest achievement in terms of artificial intelligence. You see a cat and say whether it's a cat or not, right? That's the joke that most of the AI experts say right today. Loan applications, supervised learning, loan applications, will he or she repay the loan? We already had a discussion on this. Self-driving cars, we talk about self-driving cars. How do they really work? Every single point, every single millimeter, the self-driving car goes ahead or moves ahead. There are systems that capture images. There are systems that capture radar signals, and they are continuously learning. The algorithms are continuously learning as to what its next step has to be. And then they return it. The output of that algorithm is going to be whether the car has to move ahead by another millimeter or another centimeter or not, right? And mostly self-driving cars are right now operated in controlled environments. You can't have it in India, right? For example. So the difference between using, okay, let's say image recognition in test automation versus image recognition somewhere else. It's the same thing. It's the same difference between having a self-driving car drive in a controlled environment in a country like US, where most people follow the rules and the roads are fine. Whereas automation testing, when we come to automation testing, it's like the Indian roads. We have to solve a million problems while we try and provide a solution to one thing, right? So a self-driving car will never work in India. It might take another 50, 60 years, but then it's the same thing with machine learning algorithms and and test automation. Test automation is not one single problem, it's a lot of problems, right? So we'll talk about this in the next slide. Audio, text transcript, you're going to convert an audio into text transcript. Advertising is one of the big use cases for supervised learning, mostly today's advertising, whether the ad that you put on Facebook is going to be clicked by someone else. That's one of the biggest use cases in advertising. Machine translation, English to French, you know it, I know it. Let's move ahead. So let's come to the biggest question. Why do we really need AI in automation testing for that matter, right? Just have a look at the number that's on the screen. Every month, around 1 lakh apps are released onto Google Play Store, right? Every day, there are around 3,000 to 3,700 apps that go into this app store. But the worst metric of all is around half of these apps don't even get rated by users. Around 50–55% of these apps don't even get rated. The rest of the apps which have, rest of the 50% of apps which get rated, out of that, around 30–40% of apps are usually rated below 3 or 3.5, right? So you see the problem right there. Most of the apps have a rating of 3 or 3.5, riddled with bugs and glitches. Are your apps really working? Are your apps really tested? You have 1 lakh apps, and this is exactly why you need the capabilities of artificial intelligence and machine learning within the scope of automation testing, right? So let's now go ahead and define what automation testing really is. Automation testing is not just one solution. We have web applications, we have mobile applications, we have Android, we have iOS, we have mobile web for that matter. We have APIs, we have multiple ways of testing APIs. I mean, this is an example for web application testing. You see how Selenium does it. Selenium has been there for a long time, right? You can see on the right-hand side something called model-based testing. GraphWalker.io does this. Just have a look at the graph on the right-hand side, right? The arrows going everywhere. Is this really something that's scalable? Is there a question? Hello? I heard somebody speaking. If there's a question, please raise your hand, send out the question on the chat. Yeah, so we were talking about GraphWalker and model-based testing. A couple of tools in the industry right now are, giving you this capability of creating models and testing models. They give you something called generality, but are they really scalable? Are they simple for non-engineers to create tests? Absolutely not, right? There are 1 lakh apps getting registered onto Google Play Store every single month. Are you going to create these boxes and arrows every single day? Absolutely not. This is the kind of problem that we are solving at Testsigma, right? We help you with test authoring. You can create automated tests within minutes of you logging into the application. Yeah, I mean, we'll talk about the AI capabilities as well in the next couple of slides. Yeah, so now let's speak about where you can, or where the industry is currently using automation testing. AI in automation testing. There are two major parts. One of them is object recognition. Every single application that you see on your phone, whether it be an Android APK application or an iOS application or a web application, the way currently the industry has tried to solve the automation testing related problem is using object recognition. You build a machine learning algorithm, you feed it a lot of data, you feed it 1 million images of cats and dogs, and then your application, your algorithm is going to go into the Android application and say, okay, this is the image of a cart, or this is the image of a bus, or this is a cat, right? So that's object recognition. The second part of it is text generation. So let's go ahead into the next slide and see. We'll discuss text generation after this slide. So object recognition, right? Just have a look at this image. This is the current industry sentiment where everybody is so worried that AI is going to destroy the world and robots are going to take over the world and applications are being built. But at the end of the day, a neural network that you're designing, it's showing that a cat is simply a dog. The biggest single biggest achievement of an AI device is giving you a wrong output, right? So this happens because you don't have enough data. So I put an open question to you, to all the test automation folks out there. Do we have the data available with us Do the teams that work with us, like the dev team or the DevOps team, do they give us data, or is there a way of creating or generating and storing this data? And not just the data, the metadata, as well as how you clean it and strategize it. Do we really have this sort of data right now with us? That's an open question that I pose to all of you test automation enthusiasts out there who have registered or who will be watching this recording sometime in the future. So the image on the right hand side, you can see this is a very funny pun that was created in a tele-serial on Netflix called as the Silicon Valley, in which this engineer, they design an app. Basically, it's supposed to be the Shazam of food, wherein you take the picture of a food item and the app says what food item it is, right? But they end up creating an app which is basically a hot dog or not a hot dog app. So it only tells you if a food item is a hot dog or not a hot dog. And this is precisely the problem that we are dealing with right now in AI within automation testing. We might not have the necessary data that is required for saying if these things are really what the algorithm is saying it should be, right? So you have to first collect examples of thousands and thousands and millions of food items, and then not just collect it, you have to label each one of these things. And once you label it, the algorithm gets trained, and only then can you use the data, right? So from a test automation perspective, again, the question is, do we have this sort of data to go ahead and prepare our algorithms, right? Let's go ahead and talk about text generation. Text generation is a very important part of test authoring, creating tests, right? How do you write tests? For example, an automation engineer at a peak, after 2 months of understanding the domain and understanding the product, prepares 4 test automation scripts a day. That's the maximum scripting speed that a person can achieve. An automation engineer of 4 to 6 years of experience. You first understand the product, you understand the use case for which he has to write the test case. It takes him 2 to 3 months to achieve a speed of 4 test automation scripts. Write it, run it, execute it, and see if it passes, right? What is a better way we can solve this problem with? We can use artificial intelligence to author tests, right? And if you see the man is walking down, so the next word is going to be predicted by your algorithm and say, the man is walking down the street. And this way you can use test authoring, AI in test authoring, or you can also have a model that enters values, provides test data inputs into your application. This is a big problem that we are trying to solve at Testsigma. We are trying to make the whole idea of test data generation a bit of an autonomous thing, right? We don't want our customers or test engineers to come up with test data. If you want to run your test over 100 different pieces of test data, we are going to create that for you. And my team is working on this, right? We are going to completely abstract out the idea of test data creation and give you out of the box test data through our machine learning algorithms. And this is how we are trying to solve the test authoring problem. Going ahead, so now the big question, what is the right approach? Are you going to use the self-driving cars approach, or are you going to come up with your own unique ways of solving the test automation related problems? So the Testsigma way is unique in that we understand test automation, right? The test.ais of the world may have created applications or frameworks like the Appium Classify plugin, which don't necessarily work. They are trying to solve the problem of removing the idea of an automation engineer from the process. They don't want engineers to work. They don't want manual test engineers to work. And they have failed miserably doing that. But we are not trying to solve the problem of having an automation test engineer in between tests. We want to bring quality into your process, right? Testsigma wants to bring in quality. It wants to bring quality back into the idea of quality assurance. Let's not solve the problem of human beings and the errors they cause. Let's solve the problem of quality. Let's bring in quality into your product so that when your product gets released onto the market, we say, okay, this product is going to be good. It's going to be used by most people because we have certified it, right? So we've come out with ways that can achieve this. not just through NLPs, which are a set of instructions that we're using to make the idea of test authoring faster, but we have auto healing tests. Right, auto healing tests. I do think one of the questions which were asked by the many people who registered was on auto healing tests and how auto healing tests differ between a web as well as a native mobile application. So auto healing tests, basically we index a lot of locators and UI identifiers. We see our algorithms, they completely have a look at the web pages or the mobile apps, and once that is done, we run our algorithms on top of it, and whenever a test fails, it automatically changes or it automatically updates that specific locator for that specific element on the web page. And that's how auto healing works, both for web as well as it can be native apps. It works almost the same way, right? So probably we could give you a demo of how auto healing tests work. Give us a shout out, send us an email at support@testsigma.com, or you can connect to me directly at mahesh@testsigma.com if you want to understand better as to how auto healing tests work. Right? We talk about test plan creation. Let's solve the actual problem that we face on a day-to-day basis as test automation engineers, and let's not create an application which does object recognition and calls a cat as a dog or a dog as a cat. Right? Let's solve the test plan creation problem. So within Testsigma, what are we doing in terms of test plan creation? We, for example, if there are 3 different test cases which are failing because of 4th different test case, then our application is intelligent enough to recognize that there are three test cases which are failing at the other end, and the root cause of these 3 test cases failing are the first test case, which is in a certain feature. And these other 3 test cases are the affected test cases, right? So our application is intelligent enough to creating a test plan which includes 4 of these test cases, and the auto healing takes care of the locators and UI identifiers. The tests get automatically updated, and at the end of the day, you understand exactly what failure is causing the other 3 test cases to fail, right? So at the same time, impact analysis, how even before you run the test cases, you understand what tests are going to fail at the other end. Right? So that's a magical capability that Testsigma is providing you as an automation engineer who tries to code a test. You want to understand if there is a test that's going to be failing tomorrow or day after tomorrow, right? So our algorithms take care of it. Visual testing. Visual testing is so important today. We saw this customer asking us to, there was an issue regarding, he was trying to automate a test wherein he was trying to see if an element is visible programmatically on a web page. And what we suggested was, why don't you just do visual testing, right? We are using AI algorithms within visual testing, which is going to capture all the elements and pixels out of an image and all the subsequent tests. And even if there are minute and micro differences between these images, these come out in the report. So that's where we are using AI in visual testing. Test authoring, we are solving the issues of test authoring. Now with Testsigma, you can create tests 5x faster. Bug tracking, our analytical dashboards and our algorithms help you track bugs in a much better way. Product quality metrics, right? We build products. The ultimate idea of testing is not to find bugs. The ultimate objective is to always say, okay, this product is of good quality. We are going to certify it, right? So that's where Testsigma is different from all other products or even the test AIs of the world, right? Predict production failures. The biggest problem that we are facing in automation testing is we have a million tests. We have 110% coverage. Let me say there's nothing like 110%, but we'll just say there is 100% coverage of test cases, but still there are issues in production, right? There are always bugs that are getting generated in the production environment. How are we changing this as Testsigma? We are going to help you predict those production failures through our machine learning algorithms, right? Test maintenance. Every single time a test fails, an automation engineer spends like 4 hours a day trying to repair these tests. And that really cuts down the productivity. 30% of the tests fail on a random basis whenever there's a feature change. So this is the biggest problem. We're also trying to solve this by using artificial intelligence in terms of test maintenance. Now, the biggest two things that you achieve out of Testsigma are the faster time to market. You automate your application, you automate 10, 100 different test cases within a span of a week, and then you release your product onto the market much faster than when you use a Selenium automation framework or something else, right? And automation test engineers or engineers, non-technical engineers, spend lesser time coding test cases. So that's the Testsigma way. I hope I was informative. We've already taken 42 minutes of our time. We'll just spend around 5 to 10 minutes answering questions that have been shared to us by the engineers who have registered. Hey, guys, am I audible?
Yes, Mahesh.
Hey, great. So, KR, would you like to take up some questions from this list?
Yeah, you can go ahead. I think there was one question chat. I'm just going through that and I'll take up that. But
Sure.
You can complete this. Yeah.
Sure. So, KR, also, we have received a lot of questions. We've just filtered it out to give an idea of what questions people have asked.
Yeah, we can always follow up with the answers later on this.
Yeah, absolutely.
Yeah.
Right. So the first question, what is the most significant role that AI is playing in Testsigma apart from the NLP-driven test cases? NLPs are just one place where we are using our AI or ML for that matter. I just discussed this in the previous slide. We are using auto-healing tests. It can be test plan creation. It can be impact analysis or in visual testing. We are using the capabilities of AI to the fullest. Not in a way which involves object recognition and how a different set of applications work, right? Not in a, for example, FBI uses surveillance, facial recognition, 100 different things that recognize fingerprint recognition. We don't need to do that, right? From a Testsigma test automation perspective, we are using AI capabilities to its best in giving you what are actually important to solve today's problems in automation testing. It can be auto healing, something like test plan creation. Why is my test failing? Right? This needs to be answered, and that's where we come in. So I think that answers your question. The second question is self-healing mechanism work. How does it work for native apps, and how is it different from a web page? Right. So self-healing, yes, we did talk about that. Mostly in terms of indexing, collecting a lot of locators. Every single element has a unique identifier, and it can be a CSS locator, it can be an ID, an XPath. So we collect all of these things and constantly have a lookout if this UI identifier or locator is changing, and that's the way it works for both web applications as well as for native apps. Yep. So let's go ahead on the next question. How to start with automation testing with experience in manual testing? This is a wonderful question. We try to talk to a lot of engineers, a lot of our customers, and explain to them how anybody in your team who is a manual tester can simply move on to coding test cases using Testsigma, right? So if you go on to scripting tools, you have Selenium, you have Appium, you have Cypress, you have WebDriver IO, you have Protractor. A minute of silence for Protractor because Protractor is almost dying by 2022. It's very difficult for a manual testing engineer to move into all these scripting languages, but we at Testsigma give you a very easy way to move and transform yourself from being a manual test engineer to an automation engineer by using our Testsigma user interface. We will also be providing you certifications. We'll be helping you in how to create tests within seconds, how to run your tests, and how to look at your product metrics the right way. All right. I think, guys, get in touch with us for a demo. We can show you how exactly this can be done. Now, how the pandemic has brought in changes to the process. Yes, the pandemic has indeed changed a lot of things. We're all working from home. But as an industry, I think more and more companies are moving towards digital transformation at a faster pace. Nobody wants manual work. Banks are changing the way they create accounts and the way support works, the technical support at L1, L2, L3 levels, how they work. They don't. Now, with the pandemic, what has happened is more and more issues get created and sent to the support teams. So they want everything automated. More and more testing projects are taking shape. More and more budgets are being given to the testing teams. And so as more and more apps get created for people sitting at home, we are going to do a door-to-door delivery of groceries. We are going to do a door-to-door delivery of everything. More and more budget is getting into test automation projects. And in terms of process, I think, yeah, I mean, there are more projects. In terms of a process, nothing much has changed because we're working twice as harder as we used to before. Now we work from home. Anyway, so let's get back to you with a better answer on this. Now, on the question on the shift left policy, has it changed the role of a testing engineer since a developer can test? So one thing that you always forget is testing engineer can also develop, right? We don't do it, but we can do it. It's not that we can't do it. This is something that I keep telling everybody, that the testing community is equally well equipped to create projects or create applications as developers, but we choose to stay at the point where we decide what goes into the application and what is right, if the application that has been designed by a developer is of good quality. Now, coming back to the shift left policy, has it affected the ability of a test engineer to work? Absolutely not, right? So for example, Testsigma, our product helps you in shift left. Even when your test case is not written, even when the developer has not developed that application, you can still go ahead and write that test case as a testing engineer without knowing much of a scripting knowledge. That's the way we do it. So we'd love to show you a demo of how the application works and how shift left policy will help you more than the developer, right? Now, the last question for the day is going to be, with the utilization of AI, will the utilization of AI reduce the requirement of test engineer resources in future? This is an open question. We will still have to see how AI is going to shape up in the future, in the next couple of years, and only then we'll be able to answer a question like this. Is it going to reduce the amount of work that a test engineer is doing right now? But as a joke, we always say, if you bring in an AI device which is going to replace the test engineer, then who is going to test the AI, right? So you need 2 more test engineers who are going to test the AI. Yeah, so guys, these were the questions that we received. We filtered out from those hundreds of questions from the registrants. Kiara, do you have a question from?
Yeah, there was one question, like, can you share the use cases that you have done so far and your client information, please? So one question that Sukumar had asked here in the chat. So by the way, like, I'm Kiara, like I also, I work with Mahesh on product management, and yeah. So yes, so you can please we'll ping you the website link here, and you can take a look at the clients on very high level. Like if you want the full list of client base, like you can always get in touch with us. You can write to support, or like you can reach out to any of us if you have email or LinkedIn profiles with you. And coming back to the first question, the first part of it, like, can you share the use cases? So we have done NLP so far. Like, it's not that we have picked and done completely developed all these things or use cases, whatever we discussed in the previous slide, right? So we are also taking one step at a time. Like as of now, as we speak, we have NLP engines, we have so we have auto healing in place, and we have impact analysis in place. And like, I mean, as Mahesh said, it's going to take some time for us to understand, like for example, you take impact analysis, right? It's not that we can do it immediately. We need to learn a lot about each customer data. Data means the executions or the test cases that they're set up in the system. So we have algorithms. We have that's why that's how we designed this topic. It's not just about algorithms, it's about the timing and the data. So we have it in place for impact analysis. So we are going to learn more on this as the customer progresses in their test automation journey. And coming back to that NLP, where we don't need a lot of data because we have enough data, we have enough context on like different type of applications and how can we automate applications using NLP. So that's, I would say, like, it's kind of a pretty much like 70 to 80% coverage we have on that NLP part. So visual testing, yes, so we do that full extent. So, but again, not in the holistic, like as I said, like we don't do a classification job here. We just like say right or wrong, right? Like compared to the working or like not working. So again, to say like really classify like what is right and what is wrong, it's going to take some time for us to understand this. So hope that answers your question. So Mahesh, like if a quick check, you can go back to the previous slide, like where we had like covered like
Yeah.
a few areas. Yeah, here you can see the right side, like you can see that like some of these things are like done almost. Again, we're just waiting for the data to get better. But the website, like it's something that we already have in pipeline, or where we have something in place, but we need some time, more time to make that 100%.
That's awesome.
Yeah.
Kier, so do we have any more questions?
I think that's all I could see from this chart.
Okay, great.
Let's wait for others if they have any more questions to ask. Guys,
So, yeah, guys, go ahead and post your questions on the group. If possible, we'll take it up during this session, or if you want, you can connect to us. You can connect to us at support@testsigma.com, right? Or
yeah.
mahesh@testsigma.com for that matter. And we
Yeah.
do also have a
I
poll.
think Sukumar has a follow-up question, it seems. Like, just saying 1 minute. Okay. So I was just trying to understand, like, how can you help me understand that my product is production ready? So yeah, so that so Kumar, like so when you look at from an automation perspective, like whatever the other tools are doing, right? And as of now, you say like they will just give you like either the test coverage is like 100% or not. But like, how can you really make the decisions that like your product is production ready? So that's where we have this algorithms to help you, like whether what was the severity of your failures. For example, I would say like most of the cases, like you'll have to agree with like more than 95% pass, right, and the coverage. If it is more than 95%, like you could just go ahead and release it. But so is there any risk involved in that the remaining 5%, right? That's where we use our intelligence to identify like what are those cases, how are they working with, what is the severity or the priority severity of those the remaining 5% failures. And based on that, we can tell you like, okay, so I mean, even though it's only 5% or one, even if it is 1%, and if there's one critical flow in that and that 1%, like we'll try to help you, like we'll try to tell you like, okay, this is not production ready, because even if it is 1%, so there's a critical flow failure in this. So if you're talking about like thousands of test cases, yeah, please Sukumar, you can get in touch with any of us. You can write to support@testsigma.com or write to any of us. Here we'll schedule a call to discuss in detail. Sure, thank you.